Dear friends, this is second video related with normal probability curve, in which we are going to discuss about area of normal probability curve. In last video we have seen that a perpendicular line drawn at the center of x-axis divides the entire curve into equal parts, and at the point where perpendicular line and x-axis intersect each other will get mu, that is mean, 0 sigma, z equals to 0, that is the standardized score, capital Z, that is mode, m, that is median. Moreover, we have seen that 100% of the observations are found between the curve and x-axis, and a perpendicular line divides the curve into equal parts, so 50% of the observations are found at the left side of the perpendicular line and 50% of the observations are found at the right side of perpendicular line. But friends, in terms of normal probability curve, the area between the curve and the x-axis is measured in unit, and unit is found by dividing the percentage by 100, and in that sense the measure of entire area between the curve and x-axis is 1 unit, that is 100% divided by 100. Area before perpendicular line is 0.5, that is 50% divided by 100. Area after perpendicular line is 0.5, that is 50% divided by 100. Friends, we can see here that all the areas are mentioned with 4 digits after decimal points, because a ready-made table is available to determine the area between two particular points given on x-axis, and in that table all the areas are shown with 4 digits after decimal points. Now we will see different parts of normal probability curve. For that we have to see the sigma score equals to z equals to x minus mu upon sigma, where sigma score or z score is nothing but a kind of standardized score. For each of the observations of our data set, we find z score or sigma score, and values of all the z scores of our data set will be between -3 and +3, as shown on the screen. That can be written in this way: -3 is less than z less than 3. The sigma scores or z scores for each observation can be shown on x-axis. How? Let us see. On x-axis, at the right side of 0 sigma, we can have z equals to 1, that is positive z, and the distance between 0 sigma and z equals to 1 is 1 standard deviation. Z equals to -1 is found before 0 sigma because it is negative, and the distance between z equals to -1 and 0 sigma is 1 standard deviation. Z equals to 2 is found after 0 sigma at the right side, and the distance between 0 sigma and z equals to 2 is 2 standard deviation. Z equals to -2 is found at the left side of 0 sigma, and the distance between z equals to -2 and 0 sigma is 2 standard deviation. Z equals to 3 is found after 0 sigma at the right side, and the distance between z equals to 0 and z equals to 3 is 3 standard deviation. Z equals to -3 is found before 0 sigma at the left side of 0 sigma, and the distance between z equals to -3 and 0 sigma is 3 standard deviation. Friends, we can say z equals to -3 or -3 sigma, z equals to -2 means -2 sigma, z equals to -1 is -1 sigma. In the same way, all the z's can be called. Now we will see a typical area between two points on x-axis in normal probability curve. We know that 0 sigma is there at the center of x-axis, that is also called z equals to 0, and where we will find mu, z and m. 1 sigma is found after 0 sigma, and the area between these two is 0.3413 according to the table. Area is 0.3413. It means 34.13% of the observations are lying between 0 sigma and 1 sigma, and this area can be shown symbolically in this way: P 0 is less than Z is less than 1 equals to 0.3413, where P is probability of having area 0.3413 between 0 sigma and 1 sigma. In the same way, the area between minus 1 sigma and 0 sigma is also 0.3413, and symbolically it will be written like this: probability minus 1 is less than Z is less than 0 equals to 0.3413. And the area between minus 1 sigma and plus 1 sigma is 0.6826, that is the sum of these two areas, and symbolically it can be written in this way: probability minus 1 is less than Z is less than 1 equals to 0.6826. Now we see the area between 0 sigma and 2 sigma. According to table, area between these 2 points is 0.4772, and it is written symbolically like this: probability 0 is less than Z is less than 2 is equal to 0.4772. And in the same way, area between minus 2 sigma and 0 sigma is also 0.4772, and it is written symbolically in this way: probability minus 2 is less than Z is less than 0 equals to 0.4772, and the area between minus 2 sigma and 2 sigma is the sum of these two areas, that is 0.9544, and symbolically it can be written in this way: probability minus 2 is less than Z is less than 2 equals to 0.9544. Now the area between 0 sigma and plus 3 sigma according to the table is 0.4987, and it can be written like this: probability 0 less than Z less than 3 equals to 0.4987, and the area in the same way between minus 3 sigma and 0 sigma is 0.4987 according to the table, and it is written like this: probability minus 3 less than Z is less than 0 equals to 0.4987, and the area between minus 3 sigma and plus 3 sigma is the sum of these two areas, that is 0.9974, and it is written like this way: probability minus 3 less than Z less than 3 is equal to 0.9974. Two typical areas are there which are frequently used in research, and first one is the area between 0 sigma and 1.96 sigma. According to the table, the area between these 2 points is 0.4750, and it is written like this: probability 0 less than Z less than 1.96 is equal to 0.4750, and the area between minus 1.96 sigma and 0 sigma is also 0.4750 according to the table, and it is written like this: probability minus 1.96 less than Z less than 0 is equal to 0.4750, and the area between minus 1.96 sigma and 1.96 sigma is the sum of these two areas, that is 0.9500, and it is written like this: probability minus 1.96 is less than Z less than 1.96 equals to 0.9500. Second typical area is the area between 0 sigma and 2.58 sigma. The area between these 2 points is 0.4951 according to the table, and it is written like this: 0 is less than Z is less than 2.58 equals to 0.4951, and area between minus 2.58 sigma and 0 sigma is 0.4951 according to the table, and it is written like this: probability minus 2.58 is less than z is less than 0 equals to 0.4951, and the area between 2.58 sigma and 2.58 sigma minus 2.58 sigma and 2.58 sigma is the sum of these two areas, that is 0.9902, and it is written like P minus 2.58 sigma less than z less than 2.58 equals to 0.9902. It means 99% of the frequencies are lying between 2.58 sigma and 2.58 sigma. Friends, in this video we have seen these areas like P minus 1 is less than z is less than 0, that is 0.3413. P 0 is less than z less than 1 is 0.3413. P minus 1 less than z less than 1 is equal to 0.6826. Probability minus 2 less than z less than 0 is 0.4772. Probability 0 less than z less than 2 is 0.4772. Probability minus 2 less than z less than 2 is 0.9544. Probability minus 3 less than z less than 0 is 0.4987. Probability 0 is less than z less than 3 is equal to 0.4987. Probability minus 3 less than z less than 3 is equal to 0.9974. Probability minus 1.96 less than z less than 0 is 0.4750. Probability 0 less than z less than 1.96 equals to 0.4750. Probability minus 1.96 less than z less than 1.96 equals to 0.9500. Probability minus 2.58 less than z less than 0 is equal to 0.4951. Probability 0 less than z less than 2.58 is equal to 0.4951. Probability minus 2.58 less than z less than 2.58 is equal to 0.9902. Friends, in this video we have seen different areas in normal probability curve. In next video we will discuss more about normal probability curve. Till then, goodbye. Thank you.